Thank you for coming. I'm Tom. You might know me as Tom Bereknyei. I work over at Phlox, doing some wild, crazy things, hopefully. And I was trying to figure out, I'm a Nix user for about 10 years now, I think, at least. I think I looked at Nix packages, so approaching 10, 11. I've been doing various efforts in different parts of the ecosystem, either in Nix packages or just maintaining things, trying to market it, trying to spread the good word. So at some point I'll say I'm a fanatic, but in general, if it's related to Nix, I am happy to talk about it at length. So yeah, let's get started. One thing I want to talk about is today and yesterday we were kind of doing a lot of introductions, a lot of brand new concepts, and trying to teach people. Here today I want to introduce, you probably can't get all the way to the point of having everyone kind of using all these advanced topics very early, but I want to kind of explain a little bit of why. These are some of the things that are really interesting and cool, some of the superpowers that people might want to leverage, and just knowing they exist is something I want to get out of this. Obviously, these can be complex details, complex topics, and you might need more work. All right, so yesterday we talked about like the cliff of learning, and there's all this stuff about like you gotta learn the language, you gotta learn how to like build environments, what are flakes, what's the ecosystem, what is a package. And usually once you kind of get past that cliff, all of a sudden I think there are these like huge benefits. And two that I really love are the fact that we have substitutors and that we have remote builders. So I wanted to just talk about them and introduce them. Yep. So first we have to start with some concepts. I apologize, we have to kind of do some definitional things just to make sure we kind of have a core. Copied most of these things out of the manual. That has actually improved greatly these days. So if you take a look at the glossary, take a look at the definitions, things are in there. So what is the store, right? The store, often we think about this as, oh, this is just in my machine, Nix/store. Great, that's kind of where the files go, that's where they are. And that is one instantiation of it, probably the most common one you'll see, the one you're familiar with. But there's a notion of a store that's a bit more abstract, that's just, well, it's a place where you have data that's immutable, and it can have references to other pieces of data. And the system will keep track of those references so that if you need one piece of this immutable data, let's say you move it around or you copy it somewhere or you need to like leverage it in some way, those references are tracked and remembered, and therefore you can kind of move that entire thing from one place to another. And there's a sense of integrity that this store has, more than just here's a key value store, right? So these cross links, these cross references are kept track of. And there's multiple types of stores. So if you kind of, as you start working more with this, you'll start to see a few more. You might have encountered so far something like HTTP stores, right? This is, if you go look at a cache, you'll encounter other types. So we'll go through some of those, but just understand that these other types come with different capabilities. Sometimes it's similar to what you have locally, sometimes it's different. Now you have a substitutor. Usually the way this works is that you are working locally, you want to either build something or copy something or use something, and as an optimization what we do is we say, hey, let's go find it somewhere else. And that way I don't have to build it, I don't have to do something that takes a long time. And any of the stores can actually serve as substitutors. That's a pretty powerful concept because now this one object can be used in several different ways. And then lastly, what is remote building? Well, I don't know, I have a small laptop or I have different types of machines at different places. I want to go build on them. I want to distribute work. Distributing work is a really powerful idea. The more you can do that, the better. And Nix, because it kind of saves all this information about how to build something, what it takes, all that really good bookkeeping, means now we can distribute work in a really reliable, productive way. So how can we leverage this stuff? So to learn more about this, I'm just going to put some references up here so you can get started to figure out what these are. But you can go look at the help for the stores. You can kind of see what operations the store layer allows you to do. There's a reference manual for this thing. So let's see if I can move this over. That lists various kinds of store types. It shows kind of how you can use them. They're described in this URI format. It's a little bit clunky. ideal, you could have a bit more of a structured way to talk about all the different parameters and the options you have available to you. But for the moment, it's this kind of in the query syntax URI thing. But it does what it does. So there's some documentation for that to look at. So you could look at the various kinds of stores. The most kind of first one to talk about is just like the automatic one, the thing that you kind of get when you're using Nix and you're not really worried about this thing. Auto will do basically the right thing. If you have different kinds of a multi-user install, you have a daemon, it'll connect through the socket. If not, it'll connect, it'll talk directly to your local file system, or it'll do things where it'll talk to either something that's bind mounted somewhere. But the point being, auto is usually what you're just always using, and it kind of does the right thing. But we have other stores, like there's local one is kind of very specific that says, no, use the local thing, don't be too smart. Or there's a dummy one that basically just doesn't do anything and it supports a very limited set of operations. So if you want to, let's say, just run some Nix evaluations of some expression, but you're not interacting with the store in any way, you're not putting new files in or you're not building anything, you're just kind of evaluating some sort of thing, then dummy store is kind of a fast way, a way to not even require there to even be for you to have one. Some other common one would be one that's on a remote machine, so via SSH, right? We like to do remote things with that. Another common one is S3. This is kind of where we often put things as well. And so you can kind of see some examples here of how you have other parameters and how you kind of include those options in there. Not the most, again, not the most ergonomic. That needs a little bit of work. Now, some of these stores have different capabilities. Your local store, right, obviously can build stuff. Some of these you can't, right? You can't really just say, hey, I want to go build something in like cache-nixos.org. Doesn't quite work. That would be mayhem if we did allow for something like that. And also, like, binary caches have a different goal. Like, they're optimized to do something different. So that's an outcome of that. All right, let's go a little bit more into remote builders. So this will work with any store that can do building. There's a list of those. Usually, it's going to be something like over SSH. That's kind of where it goes. There's going to be a manual for this. If you want to kind of take a look at where this goes, here's what that manual kind of looks like. It introduces the idea. It talks about how to like test this out, configure it. It kind of goes through some of the formats. It kind of gives some examples, but kind of take that and see if that's helpful to you. It's located at that URL. So let's say you have some remote machine. Let's say I'm on my, Linux machine, and I want to see if there's something on my Mac that I want to either build or push builds over there. So you can kind of start to test this out. There's like command line arguments and command line commands that lets you kind of test this out. You can also configure it that way, so when you want to do something dynamically, that's available. So you can see here we're talking about a store. Hey, SSH, ://Mac, right? So assuming I've got all my resolution and host names figured out, and assuming we've got authentication and SSH connections are all working, all the things are working, cool. This thing will say, hey, thanks. The store exists. Here's a little bit of information about it. Proceed with life. Or it'll give you some errors. This is a common place where I think people get stuck trying to use this feature set. So yes, I'm just going to acknowledge this starts to get towards the advanced side where you can kind of figure out why did it not work. What, is it that SSH isn't working? Is it because the host key is not trusted? Is it because your daemon doesn't have access but your user does? Like, there's all sorts of like weird little quirks here. Yes, it's hard. I'm just going to simply acknowledge that. Where does the configuration for this go? So one common place you can put this configuration is in etc nixconf with all your other like system level configurations, and you can kind of just use this format in there to specify a bunch of builders. You could do, basically what you say is, hey, here's how you get to this store. That's that URI for the format I'm kind of putting out there. Here's the system or systems that thing can support. So let's say, it's a way to advertise and say, well, I'm going to distribute this particular kind of a system to that particular machine. You specify usually some sort of a credential via SSH files, number of jobs, Also a factor of like how fast that machine is and how to kind of weigh between different machines when you're distributing. There's features, supported features, required features. You could put in a public key so that that whole problem with having like a host key not known is kind of resolved. A lot of these are actually optional. In fact, pretty much everything other than the first parameter, which is URI, is all optional. Again, if you go look through the documentation, it talks about what they are. Easy to mess up here as well. Again, got to read the documentation very clearly. Like a common one that I ran into is like your public key. It's got to be this base 64 format of your SSH fingerprint. Another common mistake, your daemon user has to be the one it's the one that mediates this. So if you're on a NixOS machine or you're a multi-user install, you got to kind of make sure that your daemon actually can do this. One pro tip, builders use substitutes as a configuration option. What this means is that it allows all your remote builders to directly substitute by themselves without you having to push them. It cuts down on some of the network transfer things in some cases. But usually highly recommended. Why do we do this? We like to use more machines and distribute stuff because sometimes one machine just isn't enough, just doesn't cut it. And we like speed. All right. So other reasons we might want to use this. We have, let's say, different systems, right? I have one machine with one architecture, but let's say I have to develop and provide support for more architectures. Well, I want to be able to build for them. I want to be able to test, make sure those builds work. Yes, I could push it to CI, but that's painful and annoying, and you push, and then you try again because you made a mistake, and you got to wait 10 minutes, and you push it again, and got to wait for the jobs to get picked up by your runners. Like, no, what if I just say, I want to run a bunch of builds on all my remote machines, already set, go, right? Instant feedback, faster development speed. And then when you know what you're doing, those things are all cached nicely, and you can start like pushing things with a bit more confidence. Remote builders are good because it makes things faster, right? If I want to do a large number of builds and they can be split into like smaller chunks and I can distribute them, hey, that's awesome, right? Big build graphs, something that's brand new, let's say change something very core in some sort of dependency, I'll need to do, 100 builds. Well, let's start doing them in parallel. Why not? Another example is you have a slow local machine, or let's say your local machine doesn't have really good network access, but you have kind of SSH access to something that is way faster, that's better located, closer to your caches, or closer to the internet backbone. And so here's kind of how I sometimes use it. I literally just say, hey, I'm working on something. Hey, I want to build out of my default package, but I want to build it with some combination of things. Usually this is like the kind of the 2x2 combination of things I'll build just to kind of make sure everything works. It's nice. It's simple. When it works. That's the problem. All right, so I'll try to do a demo of this. And let's see how far we can get. And that is way small. And we'll see if it works. So basically what we're doing here is I just kind of made up a random derivation and said it's going to be of those 4 different system types, right? So we got x86, we got Darwin, we got Linux, we got Arch64. And my machine is not necessarily configured to do those builds locally. I don't have anything special set up to kind of handle them. And so instead, what's really nice is I say, hey, I have these 3 other machines set up. They're connected via a tailscale network, and I got all the keys and configuration has been done. And those 4 builds got distributed out to those places. And whatever, they're really simple builds, so they actually happen really fast. They got done, and they got transferred back to my machine. All that transferring, for example, of like the builds instructions, the results back to me, right? This is all depending on these invariants of the store, right? The store keeps tracks of references. It keeps track of what that data is. It keeps track of the signatures that might be on these things. So all of that is kind of handled for you, and then you just kind of get to reap the benefits. So that's kind of nice. Actually, this might be a good spot to stop and just say, with what we've seen so far, are there any questions? Yes. So the question is, when is it necessary to stipulate auto? That's a good point. I think it's just so that, let's say you're trying to like template some command and there's a default that just works and does what the default is, right? If there was no name for the default, you would never be able to specify it, basically. Otherwise, you'd have to admit it, which is like now a conditional of some kind. I think next was you, sir? Yeah. So SSH-NG is going to be, it stands for next generation, right? It is a different protocol than you originally had with just SSH, where you're kind of talking what's called the daemon protocol. It's basically it's turning into the default because it's kind of in all respects better. There's a few slight differences, but generally, if you're going to be doing this by default, you should just be using the SSH-NG. We could go into details, but I think it might be too much. Oh, the question was the difference between SSH and SSH-NG. Sir. Yeah, so this is for remote building, and oh, sorry. So the question was, hey, I have 100 engineers, and I want to be able to do like load balancing. Can we do this via HTTP? So the remote builders are basically, it's just one kind of a subset of store types. Now we can't do builds on an HTTP store because, well, just usually the HTTP doesn't really support that mechanism to kind of send things back and forth, or we haven't implemented, hey, you do a put request and here's how it gets interpreted and all that. But what you can do is say, use something like SSH to run the builds, but then to get the product of the builds, the outcome of the builds, that comes back to you via HTTP. So I think what you might be thinking about is a substitutor, and we're going to cover that in a second in a little bit more detail. I don't know if that answered your question, though. I see. Okay. So to have a remote build farm. So some of the abstractions that would be really nice for the remote system is to be able to kind of load balance and say, here's like one kind of proxy, which is going to proxy for the other 100 builders. We don't have that yet. Right now, you kind of have to have each of your engineers list all of them. Let's say there's 100 machines. You can maybe update that file automatically. I'll show you kind of how you could do that. But that one feature you're talking about, I actually want that too, which is to say, here's your one proxy, and it will keep track of all the machines, and it's going to have access to everything. And then that way the end users only have to do like a one-line config, not 100 line of all the machines keeping track of it and maintaining it. But work in progress. So. Not that I'm aware of. So the question was, does that supported today? No, I think there's ways you can kind of hack it if you really dig into it, but basically no. Yes. Yes. So yeah, the comment is nixbuild.net works that way, right? So there's a way with what's the Nix remote configuration allows you to kind of hook into this system and do custom things. You kind of have to know what you're doing. Nixbuild.net has kind of hooked into that mechanism. There's a few other people that have tried to do various kinds of scheduling efforts to make that effective. So you can do it, but again, you have to know what you're doing. You have to have explicit support for it. And well, we just got to kind of document this better as well. A lot of this is not as well described as it should be. Sir. So the dummy would be something where, let's say, you are only trying to do some large evaluation of something, but you're not trying to build anything. So let's say you need to evaluate, I don't know, some expression, or for testing purposes. You want to just test something. That's basically why we implemented it, was because you want to test some things quickly for like, do all these expressions evaluate to the same thing? You don't need a store for that. You're just trying to test the like language and evaluation layer. You're not testing the store layer. Most people probably don't need to know about it, but it's just interesting that there's one there that's just the dummy that has no store capabilities. It's just kind of blank. Yeah. Yeah. So the question is, the Nix store has a database component that keeps track of a bunch of metadata. Is that required for the store? The answer is yes. For at least the local file system store, that database is what keeps track of a lot of these things that you need. You could remove that database and all your software will still work, but any Nix operations will not work so well. Yeah. Okay. I'm going to try to proceed a little bit then. And luckily the demo worked. I'm super happy about that. Okay, so we kind of covered some of these things. Nothing to notice. Authentication is an issue. I'm just going to kind of gloss over it, but I'm acknowledging that that's a problem you will encounter. I guarantee it. Next issue you'll encounter is signing. Once you start pushing binary blobs around, you want to sign things, and you want to make sure there's a way to accomplish this stuff. There's a mechanism for that. Again, this is in there. You sign things with these keys. You can create the keys. You can push them around. There's a standard one that Cache NixOS org uses, and during the default install, basically you're all saying you trust the NixOS Foundation to run this and not send you malicious code. That's like the core trust mechanism that does that. If you are implementing this in a company or in some organization, then you probably need to get more interested in how the signing process works. Binary caches, easiest way to get started, honestly, is just the S3 one. If your user has the credentials for it, you can copy things into it. You just say, hey, I want to push things to some bucket, ready, set, go. If you want to get involved in signing, here's some of the ways to get started. You just say, hey, I want to generate a secret. I want to convert it also to a public key, so kind of have both sides of that key pair, and I can sign things. One big issue, it looks really small, is that little tack R on the signing. That says you want to sign all the things down your closure, not just that one store path. Common mistake. But you can verify things, there's operations, you can do all this, but we want to be able to save our work. All right, substitutors under the hood. Here's how they're actually put, and here there's no database. The metadata of what depends on what is actually in these files called nar infos. Your actual data is put into those nar compressed files. So let's actually take a look at one of these nar infos. The way this works is you've got some data about what your store path is, where the actual binary is located, how it's stored, some hashes for the thing, what references they have, how someone can, what the driver is to reproduce it, some signatures. This is just the format. It's not the best format. There's some work to make this better, but it is what it is. One cool thing to note, though, is the URL doesn't actually have to be relative. So this could be somewhere else. So you could actually have your nar info, your metadata, be put into a completely different place than you have all of your binary data. I think that's kind of cool. So I kind of came up with a crazy idea. What if we actually put some of these things in different places, right? You can kind of put them somewhere else. And if you want to go take a look, I decided, hey, what if I put them into GitHub releases, right? So GitHub lets you put something into your releases. And if you go take a look at this, I've uploaded basically exactly the same files you saw earlier, if it's familiar. And now you've created basically a HTTP Nix-compatible binary store that just kind of works out of the hood. It's kind of fun. It's kind of quirky. It's interesting. It might actually be useful for some people, right? Because let's say you don't want to have an S3. You don't want to run some server. And here's some company that gave us some storage for free. I think it's up to 2 gigabytes or something like that. But hey, who knows? Might be fun. But there's flexibility in the substitutor system. And here's just one way to leverage that capability. If you want to play with that, I have that under Tom Bereknyei GitHub store. If you want to play with it, there's a little app that kind of shows you that you have to like tag a release, then you upload the files. We have to do a little bit of sed replace to make the URLs work right with how like Nix usually does them. So you can kind of see what that is doing, but it's quirky, it's fun, it's interesting, who knows. All right, let's get this back. Okay, so as a recap, Nix has superpowers, right? We have these core concepts, we could do a bunch of like really nice things, and we want to be able to leverage them and expose these like superpowers, not just to like experts, but how do we make it that like those 100 engineers that were mentioned a second ago all have access to this without having to learn all of it, right? So that means we got to make the configuration easier. That means we got to make error messages better. It means we got to kind of document this better. It means we have to discuss it better and expose this to people, right? If it's just us using it, what's the point? I mean, I want to be able to make it so that as many people as possible benefit from this, so that when your coworker builds something, and then you build basically the same thing because you're testing their PR, why are you rebuilding it? Just use the same bits that they just used, right? There's entire organizations in like large companies that what they do is they go, hey, we're going to ship around today's development cache to all of my engineers. And they do this like every morning and they push it around. It's a 4 a.m. job. Like, I mean, this sort of thing is Nix just kind of solves. We should just leverage it and expose it, make it easier to use, nicer to use. It needs a lot more work. Hands down, I agree. This is something that just needs more attention in the Nix code base itself and our documentation in the ecosystem. So if you're interested in these things, like, get involved, right? That's kind of my call to action here. A lot of what I talked about today has nothing to do with the Nix language. I don't think I actually showed a Nix expression at all, maybe, I hope. This is all store layer things. Like, this is a store layer, this is reusable, has nothing to do with Nix the language. In fact, this store layer is usable by other systems, and that's kind of the intent. Famously, GUIX, Geeks used that like underlying store system, and we want to make this underlying store system more accessible to other people. All right, we discussed substitutors, remote builds, and we did a little fun little kind of trick you could do with substitutors to kind of put it into an unexpected place, which I think was kind of fun. Questions? Oh. Sir. No. So now if you try to build something and it's figured out that, oh, I need to build it, and it contacts that machine to build it, that machine will go, I've already got it, here you go. So you do kind of get some of that, but it's not technically speaking in the config a substitutor. It's just kind of behaves in a similar way, or the outcome is very similar. The question is, if you have a remote builder, is it automatically a substitutor? And the answer is, strictly speaking, no, but it does behave, you get the benefits as if it was. Sorry. Oh, one more question in the back, all right. So that's okay, do I have experience with Attic? And how's that play to us? So there are smarter stores, basically, we'll call them, and store implementations that are out there. Attic is one, tvix has them, and basically, like, yeah, there's tons of additional features you can kind of provide, which I think is awesome. It's just that oftentimes the people implementing that kind of have to struggle with, how easy is it to create that thing over the long period of time? Can it be supported? What happens when upstream changes something and now we like break some part of the protocol? So that protocol's got to be better, it's got to be nicer, again, documented, needs work. So my goal is to make those things easier to build, easier to maintain, and easier then to provide those features to, well, the broader world. That's the goal, right? That's it.